All right, so now let's suppose that we have a function, let's call the function z, and let's say we have it defined implicitly by an equation, yz plus x ln y equals z squared. So z is a function of x and y, and it's the function that satisfies this equation. Right? So you might remember doing something similar to this in Calc 1, where you have y is implicitly defined as a function of x, and then you found dy dx by taking the derivative of this equation and sort of solving for dy dx. Well, we can do a similar thing here. We can find both partial derivatives of z by doing partial or implicit differentiation on this. Right? So let's see how to do that. Right? So I think the best way to do this is, remember, z is a function of x and y, right? And then just hit this whole equation with the derivative. So d dx of yz plus x ln y equals z squared. It's fading out there. All right, let's switch markers here. Right, so I'm just taking d dx of this guy right here. All right, so now let's do that. So d dx of this first guy, y times z, well, remember, y is a constant as far as x is concerned. So all we get here is y, let's put a little arrow here, dz dx. Right, because z is a function of x, so we have to take the derivative of z with respect to x. Okay. Plus x ln y, well, remember, y is the constant, so ln y is basically a constant. Right? And then we have to take the derivative of z squared. Well, z is a function of x, so we have to chain rule this guy. So we get 2z dz dx. Right? Well, and now we just have to solve for dz dx. So we take this guy, move it over here, factor out the dz dx, and then divide. Right? So this says that 2z minus y dz dx is ln of y, which tells us that dz dx is ln of y over 2z minus y. So that's dz dx, right? And this should basically look just like implicit differentiation from Calc 1. Okay? So let's do it again for the other one. And let's do this. You pause the video, try it yourself, and then check your answer with the rest. All right, so let's start. We're going to take d dy of this equation now. So d dy of yz plus x ln y equals z squared. All right, well, this time it's a little different in the first term because both y and z are functions of y. So we have to do a product rule here. Because z, let's do the arrow again, z for the first part of the product rule plus dz dy. The derivative of the first times the second plus the first times the derivative of the second. ln y, well, x is the constant now. Derivative of ln y, hopefully you remember, is 1 over y. So here we just get x over y. And now z squared. Well, that's basically the exact same thing from as we had up here. This is again going to be 2z dz, but this time dy. Right? So now we move y dz dy over here, factor out dy, and then divide by 2z minus y, and this tells us that dz dy Well, this is going to be z plus x over y over 2z minus y. Right? And if this x over y in the top bothers you, you can multiply by y over y. And that'll give you that this is zy plus x over 2 zy minus y squared. Either one's fine. This is easiest to get to. This is making it look a little bit nicer. Either way you want to do it, completely up to you. Unless for some reason the problem you're given specifically tells you to get rid of such things. But anyway, so this is all there is to implicit differentiation. Again, just like you did in Calc 1, except now there's x's and y's. Maybe z's, so you might have w as a function of x, y, and z. You know, you can always go up more. You can even go to 4 variables, 5, 6, so on. There's nothing stopping you, and the procedure's pretty much always exactly the same. Okay?